7-4 in geometry. Today we're going to use similar triangles to estimate the height of really, really tall objects. So the key word here is that we're going to estimate this because not everything in this world is an exact science. So here's what we got. Big Willie waited till his and the tree's shadows coincided. That means that they lied right on top of each other. Big Willie is 7 feet tall, so we're going to put that in the picture right there, that he is 7 feet tall. And his and the tree shadows are 8.25 feet and 19.25 feet respectively. So here's what that means. Like the shadow for someone will be on the ground, right? So here's Big Willie's shadow right here. It's going to be 8.25 feet in that case. And then the tree shadow I'll do in blue right here goes from the tree all the way over to here. Right, that's 19.25 feet. And do you see how Big Willie's shadow lied right on top of that one, and they end here basically at the same point. It says find the height of the tree rounded to the nearest foot. So what we'll do is we'll just kind of call that X. So imagine this is the height of the tree right here, and we'll call that X. Well, first of all, what does this have to do with similar triangles? It's this. We're assuming a lot of things here. That's why it's an estimate. Sorry about that, guys. So the estimate's going to be that, one, we're assuming that the ground is flat, right? So we always know that it's not always that way, and that this tree is growing at a 90-degree angle. Trees don't always do that perfectly, so Big Willie is standing there. So right there, we can say that we have one set of angles the same. To help prove these triangles similar. And then the other thing is we've got this triangle right here in green. He is totally inside of this giant red triangle right here. So they share this angle right here. So these triangles are similar by angle. And what we'll do is we'll do a scale factor. So I know these two sides, they correspond to each other, and I'm going to do big over little. So I'm going to do my scale factor of 19.25 over 8.25, and I don't care about reducing that one bit. We're just going to leave it like that, and that's going to be proportional to, if we do big over little, X over 7, because these sides correspond to each other as well. So we'll do a little cross multiplication. I'll do 19.25 times 7, and I got 134.75, and that's going to equal 8.25x when I cross multiply, and then we will divide by 8.25, so divided by 8.25, and I got me 16.3 repeating. So I'm going to write it down like that x is about 16.3 repeating, but it says round to the nearest foot, so math rule says since that's 0.5 or less, it's going to be about 16 feet tall. It's just an estimate because it's not truly exact due to the fact that the ground might not be perfectly flat. Those angles might not be exactly 90 or the same or anything like that. So we're just doing an estimate to the nearest foot right here. So we got Farmer Brown. He was curious how tall his family's 100-year-old grain elevator was. So that's this giant building right here. And he aligned himself with the shadow of the grain elevator and measured his shadow to be 7 feet. So here's Farmer Brown's shadow, 7 feet, while the grain elevator's shadow was 63 feet 6 inches. So what we're going to do is we're just going to change that into the same unit of, I'm going to use feet. So it's got 63 feet, and then 6 inches is actually a half a foot, so that'll be 63.5 feet in that case. Farmer Brown is 5 foot 9 inches tall, so I care about those inches. So that is 9 inches out of the possible 12 inches that make a foot. So as a decimal, 9 inches is 0.75. So he's 5.75 feet tall in that case. The other thing you always got to put for me is why these two triangles are similar. So we'll put the 90s in there and the shared angle so we get some angle. And then we just set up the proportion, baby. Big over little. I know this side corresponds to that side. So 63.5 over 7. That's going to be proportional to, I'm looking for the height of that grain elevator right there. So that's going to be X over 5.75. And we solve with cross multiplication. 63.5 times 5.75 times 5.75 gives us 365.125. And that's going to equal 7x. And then we divide that bad boy by 7. And about 52.2-ish is what we'll do. X is about 52.2. That's in feet, but they say to the nearest foot, so we'll say it's about 52 feet tall. I still like to put the decimal to show people that, hey, it didn't come out perfect or anything like that. But when we're rounding to the nearest foot, because that's what they tell us to, that'll round down. So now on our next one, we got to draw our own picture here, right? So Rick waited till his and the flagpole shadows coincided. So we're going to need Rick. We're going to need a flagpole. And then they just give us information about how tall Rick is and how tall the shadows are or how long they are and everything. Find the height of the flagpole. So first thing we need to do is like draw the ground, right? So we'll use a straight edge, no freehanded. And then, except for the like stick figure and everything, but all the straight parts we're going to draw straight. There's a flagpole as well. And then what we got to do is we got to like connect from the top of the flagpole. It's got to still be touching the top of his head. Like it can't be up here. Like that's not going to work. We can't draw a triangle right there either. It's got to be to the top of his head all the way over to the ground. So sometimes you got to extend your ground out just a little bit longer to make our two triangles right there. We get ourselves our 90-degree angles and, of course, put that shared angle inside of there, and then we'll go put our stuff in there. Rick is 6'3", so 3 inches out of the 12 possible means that's 0.25 feet. So 6.25 feet is how tall Rick is. His shadow is 13 feet. Sweet. And then the flagpole, I like to put this little big old bar right here, say I'm talking about the whole thing, is 40 feet 6 inches. So again, 6 inches, if you didn't know, is half of a foot in that case, like 0.5. So 40.5 feet. And then we're looking for how tall that flagpole is. So we will do our proportion. 40.5 over 13 is going to be x over 6.25, baby. And then we will cross multiply 40.5 times 6.25. Boom. 253.125 is going to equal 13x, and then we shall divide that by 13. See what it comes up to be. Oops, I hit 12. How about 13? There we go. About 19.5. X is about 19.5. Let's go back and see what they had us round to. Round to the nearest foot. So, ooh, interesting. Maybe we need to make that 19.47 because it really wasn't 19.5. And then we have to probably round that down, to 19 feet instead of to up to 20 feet. So it's about 19 feet tall. It's kind of one of those right there in limbo land. Is it 19.5 or is it not 19.5? So it's like you kind of had to round it up to 19.5, then that means you would have rounded it up to 20. So just got to be a little careful with that one. Braylon was curious how tall the scoreboard was at the Hayes High football field. She's 4'9" tall and lined herself up with the shadow of the scoreboard, which was 85 feet long. So she's 9 feet away from the end of the scoreboard shadow. To the nearest foot, how tall is the scoreboard? So to draw a picture, once again, do the ground, draw your person, draw your objects. Scoreboard's pretty tall, so I kind of made that appropriate. You don't have to be artsy or anything, just at least like maybe label what it was. It was a scoreboard, and then make that connection from the top of it through the top of that person's head. And then we get our 90s and our shared angle. Those two triangles are similar. So she is 4'9". That is 4.75 feet. And it says the scoreboard shadow is 85 feet long. So, okay, 85 feet. And Braylon is 9 feet away from the end of the shadow. So that would be this. Okay, 9 feet. How tall is the scoreboard? To the nearest foot. So same old story. 85 over 9 is going to be proportional to x over 4.75. So cross multiply. 85 times 4.75. Booyah. 403.75. And that's going to equal 9x. And then we shall divide it by 9. And that scoreboard, about 44.9. And they say round to the nearest foot, so it's about 50 feet tall. And there we go. Scoreboard in. And then just another review from similar figures. So again, check this guy out. They told us these dudes are similar right here. We'll start with our basics of big guy and little guy right here. And to find a scale factor, I got to find two sides that correspond to each other, and I know both their lengths, right? So I can start with this 45 in AB. AB corresponds to EF. Let's see if I know EF. I do not know EF. He is an X in that situation, so I can't quite use that dude, so not going to do him. In this dude, I have DC, which is 21. DC goes with GH, and I do know GH in that case is 14, so my scale factor, big over little, is going to be 21 over 14. And that totally reduces, right? So I'll do a little SF to show people what I'm doing. Scale factor is 21 over 14, which 7 goes into each one of those, so that's going to be like 3 over 2, baby. Then, if I could write 3 over 3, 3 over 2 looks better. Measure of angle F. You could go crazy with this all day, but I'm going to let the similarity statements tell me who goes with who. So they want F. He's going to correspond with B in this case, so I know the measure of angle B is 53. And don't forget that corresponding angles in similar figures, they are congruent to each other, so I don't need any scale factor. If that dude's 53 in this dude, he's got to be 53 down here, so I'm going to put that in my picture of 53 degrees as well. Measure of angle A. A comes first. He corresponds with E. I know E is 50 degrees, so A's got to be 50 degrees as well. And then to find X, X is a side length, that's when we'll use the scale factor. So we'll start with 3 over 2, and X corresponds with that 45. We did that earlier. EF goes with AB, right? So got to do big over little, so 45 over X. That's the hint of putting the B's and the L's. There's no way you should mess that up when we're always doing big over little. So cross multiply, 3X equals 90, and then divide, X should equal 30, baby. Then the ratio of the perimeters, don't need to know anything about the actual perimeter. It's all about the scale factor, and it would be the scale factor to the first power, because perimeter gets the first power. And area, it would be the scale factor to the second power. So 3 squared is 9, and 2 squared is 4. So ratio of their areas. Sweet. Let us know if you have any questions. Have a good one.